This simulation was designed to allow students to visualize and determine the relationship between the wavelength of a wave, the frequency, and the speed of the wave. What students will do is click on the begin button, and then they could just click on the start button, which will start generating a wave. I would suggest to start out by finding the speed of the wave through this medium, and just allow the wave to grow to a certain size. I let it grow till it reached the 300 meter mark. Each of these big blocks is worth 100 meters. And it took 10.27 seconds for it to travel 300 meters. So students would then find the velocity of that wave. They would then do a few different frequencies and measure the frequency and wavelength to see how frequency affects wavelength. They would do this by starting with a new frequency, and then they just count the number of waves that occur in maybe 10 seconds. And they don't need to get exactly 10, but in this case we don't count the first wave, that's wave 0. So we have 1, 2, 3, 4, 5. So we get about 5 waves in 10 seconds. If they'd like, they could extend it out until the 6th wave starts, and 6 waves in 11.5 seconds. Okay, they can do any combination of cycles and time they want, but their goal is to figure out the frequency of the wave. Once they got the frequency, they then want to measure the wavelength. I would suggest trying to have them get one of the wave fronts, get as close to one of the dark lines as possible, and then as best they can, estimate the distance to the nearest wave front. This will give the students the wavelength. They would then repeat this process for a few different frequencies. And again, they want to count the number of waves that occur in a certain amount of time, and they want to measure the distance the wave traveled from one wave front to the other. Once they do this, they should get a nice graph relating wavelength to frequency. Once they've established this relationship, they want to keep the frequency constant and do a bunch of different wave speeds. And they can clearly see the change in wavelength that happens at different speeds. Again, they need to find each speed through a little bit of calculation, having the wave travel a certain distance, in this case about 315 meters, in a time of about 3.5 seconds. They would again graph out wavelength versus velocity, and again get a really nice relationship. So at the end of this lab, students should be able to visualize why the wavelength changes with both frequency and velocity, and hopefully generate an equation that relates these 3 variables.